So you've heard some really big views on maritime matters, shipping matters. Now we're going to dive into something that is a piece of the puzzle when it comes to efficiency. And I thought I might name the presentation "What the Hull is Happening," but thought that might be a little too provocative. So we're going to talk about hull and propeller performance, monitoring, analysis, benchmarking, recommendations. It's possible to outsource ship performance analysis. We own a mathematical performance model where ship owners provide main dimensions, trial data. It's entered into this model, and it's run by naval architects who are analyzing the performance data from the vessels. And then that data goes back to the ship owner's technical department, and in some cases out to the ships and the crew for awareness and implementation of hull and propeller performance policy. So there's a general mathematical model, and main dimensions and trial data are entered into that model, and then a specific ship model is created. And then the weekly performance data is submitted where it's analyzed, and there's checks for instrument readings, reading correctly, procedural checks, have the crew collected the data properly, and coefficient adjustments, wind, waves, wake resistance. And then from there, reports are churned out every month. And from this experience, we have over 468 dockings, combined hull and propeller cleanings 330, discrete hull cleanings 117, and 341 propeller cleanings. So you can see here there's a lot of evidence or empirical data. A lot of ship owners are combining a partial hull cleaning with a propeller polishing, and hull cleanings when necessary, but of course there's the chance of damaging the hull coating. So in this entire spectrum, at any particular ship owner, you have performance monitoring, performance management, and then operational optimization. That's probably the most interesting, where you look at how the organization is made up and what type of policy is set depending on the ship type and the operations and the use of data. It's often said that's one thing that separates one company from another is how they use data. Everybody has nearly the same data, but it's how do they use that data. And also the saving potential goes up as the commitment goes up. So what is the purpose of hull and propeller performance analysis? Establishing economically optimal intervals for hull cleanings, if required, propeller polishing. Compare fuel consumption for different hull coating systems. I think everybody knows the coating suppliers these days are making some quite prolific claims on fuel savings attainable from using their coating systems. ISO is developing a standard for evaluating speed decay over time in an attempt to give a level playing field to the hull coating suppliers. One thing that we have seen is a lot of the fuel savings that come from hull coatings is because of the blasting of the hull, not because the coating itself is so phenomenally smoother than another coating. Reducing the client's need to develop and maintain an accurate fuel consumption system and validating that ships are performing in accordance with charter party. Of course, in SEMP, there's some discussion about hull and propeller resistance management. And that can go from the entire range of we look over the side of our ship to see if it's fouled, all the way to a more sophisticated approach where speed and fuel losses are accounted for due to hull and propeller condition by correcting the performance variables. So unique data collection procedure is required. This type of system, you usually cannot use noon data. Noon data has a lot of, the 24-hour average of noon data presents a lot of changing variables. And so to put it simply, when the ship's in steady state, it's easier to get a good snapshot of the performance of the ship. So it's also important in a robust performance analysis system to have some checks with meta-ocean data. This could be the global real-time ocean forecast system or the near real-time global ocean surface current models, and to help correlate the position and course of the vessel with the hindcast weather data at that time. Because slight changes in sea state can cause an enormous change in performance of the ship. So the point of this is to correct the performance data so that you can come up with a actual smooth curve from the scatter and performance data. And it seems to me that the discussions at IMO about MRV and SCEMP, as Panos had mentioned, are going to drive more and more interest in this area. The SEMP plan these days doesn't have a lot of teeth, so to speak. It's some basic format and guidelines, but word on the street is that soon SEMP will become a more serious document with goal setting and more accountability on improving vessel performance. So what factors are in your control? If we correct for the wind, waves, sea current, draft, trim, fuel oil quality, and you want to improve the performance of the ship, you have hull coating selection, silicone, anti-fouling, different types of coatings, and every few years there's another latest and greatest coating on the market. Frequency of in-water husbandry. Do I polish my propeller every 3 months, every 6 months, every 9 months, if at all? Efficiency of in-water husbandry. There's several new hull cleaning robots coming out on the market. Some have been around for a long time. And so there's this discussion if a unmanned or autonomous robot can clean the hull as efficiently as divers with machinery. And blasting of the hull. From our experience, one of the greatest performance losses on vessels sailing the seas these days is the minimal investment made in dry dock. The 10% blast area on a second or third special survey, and you're leaving about 10% performance sitting on the table that you could have achieved if you did a full blast of the hull. Energy-saving devices. I don't have a lot of experience with that, but a lot of them work in a specific speed regime. They're not effective at low speeds, but they're effective at high speeds, whereas if you do a blasting of the hull and a good investment in the hull coating, you have a energy efficiency that rides with the ship its entire docking cycle at all speeds and drafts. So what does this change in hull and propeller resistance look like? There's a typical graph of propeller polishings, hull cleaning, idle time. And then, of course, the resistance translates into speed consumption curves. Blasting of the hull, there's an example of two sister ships, and the ship with the greater blast area produced a 14-ton day saving more than the other vessel. It's a big container ship. Example of a hull cleaning and a dashboard showing what this looks like before and after the hull cleaning. I'm running out of time here. So this is where a whole fleet can be plotted in one graph, and you see the vertical axis, how fast is the hull and propeller fouling. The horizontal line, how much has the resistance of the ship increased since last dry dock. And then, of course, if you have ships that are fouling quickly and they have a lot of extra resistance, then they're in this reddish zone in the upper right quadrant. So it's easy to look at the, and then the green, yellow, and red are how long the ships have been out of dock. So here's how a fleet changes over time, and this is a fleet of 50 ships where you see that maybe idle time pushes the ship up over the threshold. Some of the ships going out over a threshold, they've cleaned the hull and they've brought it back into a more reasonable performance. So, like I said at the beginning, this is just one piece of the puzzle for all the topics in terms of energy efficiency, and there's other experts, I'm sure, that will speak on other topics related to this. Thank you.